Hello, I'm Breton, one of our MCAT tutors here at Inspira Advantage, where we help students get into med school and other professional programs. Today, we are going to dive into the important parts of glycolysis you need to know for the MCAT. If you haven't already seen our overview of metabolism video yet, I highly recommend you give that a look before watching this one. Let's begin by thinking about what the inputs and outputs of glycolysis are. For inputs, we have glucose, we have 2 NAD, we have 2 ATP, and then coming out, we're going to make 2 pyruvate, 4 ATP, and 2 NADH, and 2H+. So a little bit of acid. When we first take a look at all of the enzymes in glycolysis, like we do up here, it can be frightening to think that the MCAT expects us to know all of them. Luckily, you really need to only be able to recognize most of these enzymes as having to do with glycolysis. You just have to recognize them. You don't have to know which each of them does. However, there are a few key enzymes that you will want to know exactly what they do, make, and use. Additionally, you're going to want to know who's making ATP and NADH, and where is this happening inside of glycolysis. We'll also want to know which steps are irreversible, which I'll give you a hint. There are 3 irreversible steps. Do you remember where they are? Let's start with where ATP is being used and made. Near the beginning of glycolysis, 2 ATP are invested to move the reactions forward. Because ATP is used to move this reaction forward, it tells us that this reaction is irreversible. It literally is taking outside energy to proceed. This means it is not spontaneous. The enzymes that take this initial investment are hexokinase, or HK, which I will show here as ATP comes in, ADP comes out. We've got hexokinase HK, and the second irreversible enzyme that is also using ATP is phosphofructokinase. This is an extra important enzyme to know because it is the rate-limiting enzyme for glycolysis. This means that as fast as PFK can run is how much sugar can be processed, how much glucose can be processed. But don't worry, glycolysis is going to make a good return on this investment of 2 ATP, 100% return, in fact. It's going to obtain 4 ATP in the end for a net gain of 2 ATP. And this is during the last half of glycolysis. The enzymes that are going to produce ATP are 3-phosphoglycerate kinase, or 3PG, and the last step, pyruvate kinase, or PK. Notice how all of these enzymes that deal with either using ATP or producing ATP end in the word kinase. This just means phosphorylation. This is a really good tip to help you remember and troubleshoot on test day when it says, hey, which one of these enzymes has to do with ATP? Hexokinase, G6P, F1GB. Oh, it's got to be the kinase. It ends in kinase. Kinase tells us we are doing something with phosphorylation, which is what ATP is all about, really. Now, earlier in this video, I mentioned that there are 3 irreversible steps that all have to do with ATP. The first 2 we've already hit. I'll do a gold star by these. We've got our hexokinase, we've got our phosphofructokinase. Now we need to talk about the third. The final irreversible step is the very last step in glycolysis. This is pyruvate kinase. And this makes sense because if you think about what would happen if pyruvate kinase wasn't irreversible, well, then it would be really easy for the pyruvate we just made to then start returning back up the ladder, moving back towards becoming glucose. And we can't have that. That'd be a huge waste of energy. We invested the 2 ATP. We don't want this reaction to suddenly start going backwards, at least all the time, without proper regulation, which is something we'll talk about in our next video on how do we actually regulate this process. So we've talked about the ATP story. Now we want to figure out where are we making NADH? NADH is huge for energy. This is where we make the most energy, is through oxidative phosphorylation of NADH. There is one enzyme in glycolysis that is going to produce NADH, and it is glyceraldehyde 3-phosphate dehydrogenase, or GAPDH, right in the middle. I'll show this in blue. So you can see we have NAD plus coming in and becoming reduced to NADH. NADH means that it is going to be carrying our electrons. Much like with the suffix kinase, the suffix dehydrogenase tells us that we are going to be producing electron carriers like NADH or FADH2. I want to thank you for watching our video on the important glycolytic enzymes you need to know to do well on your MCAT, and I will see you next time.